All right, this is 10.1 polar coordinates. So we're going to take a look at how to graph in the polar plane. And before I go into this, I have created a link for you that basically if you follow the link in Google, it will come up with different polar paper. So I just wanted to let you know about it now. So go ahead and, download a couple pages for your homework, because I don't know about you, but if you go to Target or Walmart or wherever, you're not going to be able to find polar paper there. So you can get off the internet for free. All right, now that I said that, let's go ahead and check out objective number 1. So we're going to be looking at polar coordinates, which means we're going to have to use polar paper because we're going to be using what's called a polar plane. So polar planes are circular in nature, and an angle or a point on the polar coordinate has the values of r comma theta. So we no longer have x comma y like we do in the Cartesian. The r stands for the radius, and theta is the angle. And I do want to point out that our angles are running counterclockwise. That's a positive angle. If they run in the clockwise position, we have a negative angle. So this is exactly the same way as when we were studying right angles earlier. So the radius is the distance from the pole or the center out to that point. And we also have the polar axis. So, if you're looking at a Cartesian axis, this would have been the x-axis where x equals 0 degrees. So let's go ahead and check this out. So once again, r and theta. So r is the radius and theta is my angle. So let me fix that. I put that in the wrong spot. So theta is the angle. Okay, so let's check out what a polar grid looks like. So as we can see, here's one that I posted in your notes that's off the internet. And it goes in degrees. And it basically hits all the degrees in the 0 to 90 degree realm. But then as we go around, it gets a little sparse. So just note that every 2 sections becomes 30 degrees. So 45 would be in here. For instance, if we wanted 150, I would go 2 units up, so 150 would be right here. So I'm just showing you that you can fill it out however you need it. Okay, so that's what our polar grid looks like, and notice that we go all the way around, so 0 is also 360 degrees. Okay, so let's check this out. Plot the points with the following polar coordinates. So the first one is, for part A, is 3, 5 pi over 3. So if you know the unit circle really well, you'll notice that 5 pi over 3 is equivalent to 300 degrees. So we're actually looking to plot 3, 300. So what we're going to do is we're going to basically hit this fourth quadrant here. So 270 plus 30 gives me 300. 300 plus 30 is 330 degrees. All right, so 3, 300 is what we're looking for. So I find the 300, and I'm just going to lightly do this. So this is where I'm at. So I've done this. So basically, I've gone all the way around to this end. And now I am going to grab another color, red, and I'm going to plot the point. So the radius is 3. So I find 3 rings out from the center, 1, 2, 3, and that's my point. So this point here, once again, is 3, 5 pi over 3. Okay, so let's go ahead and check out B. B says, hey, I want to plot 2, negative pi over 4. So remember that pi over 4 is equivalent to 45 degrees. So I'm actually looking to plot 2, negative 45 degrees. So once again, just like we did before with the negative angles in the Cartesian coordinate system, you are going clockwise. So this is 0. Here's negative 30 degrees. I go 2 spots over, I get negative 60. And in between the two is negative 45 degrees. Okay, so 270 is no longer 270. This is negative 90 degrees. All right, so I'm going to find negative 45. So I'm going to put a line here, negative 45. That's where I'm at. And remember, this time around, I am going clockwise. And the radius is 2. So the point where I have right here in red is 2 comma negative pi over 4. So we have two more that we have to do. We have to do 3, 0, and negative 2, 45 degrees. So let's go ahead and do part C. Part C says 3 comma 0. So my angle this time around is 0 and my radius is 3. So I go to where it's 0 and I'm going to go ahead and put a dot here. And the radius is 3, so voila, I'm done. Okay, so that one was pretty easy. Let's check out part D. So D asks us to find negative 2 comma pi over 4. So the negative radius is not really tricky if you know what you're doing, but it can be if you don't. So this one we got to talk about it. So if you have a negative radius, what you're going to do is you're going to plot the point with a positive radius. That should be I. So plot the point with a positive radius. And then what you're going to do is reflect 180 degrees. Okay, so let me show you how this works. So what I'm going to do is I'm going to plot, in this example, 2 comma 45 degrees. Okay, so I'm going to do this in blue. All right, so I find 45 degrees, which is on this line here, and I'm going to take this and extend it down because I'm going to have to take, remember, I'm going to have to take and reflect it 180 degrees. So that's this line right here. So I'm just going to make this a little bit dark. If I plot 2 comma 45, I'm on the second ring and 45 degrees, okay? Now, in red, I'm going to reflect that point 180 degrees. Remember, 180 degrees is a straight angle. So I'm staying on the 2 ring, and I'm just going to reflect my point 180 degrees. So my answer is right here. So this is my answer. And I just plotted negative 2 comma pi over 4, or 45 degrees. So once again, if you have a negative radius, be careful. What you have to do is plot the positive radius with the angle and then reflect it 180 degrees. So if you're in quadrant 1, your answer will be in quadrant 3 if you have a negative radius. If you're in quadrant 2, your answer is going to be in quadrant 4 with a negative radius. Okay, so the beautiful thing, just like we did in Trig, is we can name the same point in polar graph with other names. For instance, if I look at figure 7, I'm looking at this. My original point is 2 pi over 4. Okay, so I'm on the second ring, angle's 45 degrees. If I rotate all the way around and come up again, now I have pi over 4 plus 2 pi. So pi over 4 plus 2 pi is 9 pi over 4. So I can also name this point, same position, 2 comma 9 pi over 4. The other thing I can do, and we kind of saw it in the last example, is we can rotate in a negative manner, meaning going clockwise, and we can call that point 2 comma negative 7 pi over 4. And finally, we can use a negative radius, but we have to be careful with this. So if I want to end up in the same position, remember my angle has to be 180 degrees from that. So remember that this was pi over 4, and then I take and move it 180 degrees. So now I'm at 5 pi over 4. So how do I name this point? Well, the radius is still 2, so I call it negative 2 comma 5 pi over 4. So let's go ahead and check out this next example. It's going to ask us to plot the point P with polar coordinates 3 comma pi over 6 and find other polar coordinates r theta of the same point. So all we're going to do is we're just going to name it given the stipulations, part A, part B, part C, and part D, so A, B, C. So let's go ahead and look at part A. So part A says the radius is greater than 0, so my radius is positive, so I don't have to do the 180 degree thing, and my angle is between 2 pi and 4 pi. That means that I've moved all the way around the unit circle or sorry, not the unit circle, all the way around the polar coordinate grid, and I came back right around again. So first of all, I'm going to plot this point, 3, 30 degrees, because all the points will share the same value, okay? So once again, I've gone all the way around and then back up again, okay? So what is that value? Well, if I rotate all the way around, I need to find pi over 6 plus 2 pi. So if I find a common denominator, I get pi over 6 plus 12 pi over 6. And when you do that, you get 13 pi over 6. Okay? So if my radius is positive, my radius is not going to change. The value is going to be 3, 13 pi over 6. And that is my answer. That is equivalent to 3, pi over 6. So let's do B. So B, once again, let's plot the point really quick. So here is 3, 30 degrees. For part B, it says the radius is now negative. So radius is negative. And my value has to be a positive angle between 0 and 2 pi. So here's an instance where we have a negative radius. So that means I have to flip-flop. Okay, my ring is 3, not 2. So I'm going to go ahead and just make little dots here, just to let you know that's what ring I'm on. And if I have to use a negative radius and I want it to end up being at this point here, I need to find what this point is. So what is the angle there? Okay, so this is pi over 6, remember, right? And 180 is pi. So what I have to do is add pi plus pi over 6 to find out where the point where I put the x is. So this becomes 6 pi over 6 plus pi over 6, which equals 7 pi over 6. Okay, so the radius is negative. The angle that I'm going to have to use is 7 pi over 6, and I'm going to use a negative 3 radius. So that means, hey, plot 3, 7 pi over 6, and then reflect it. And if you reflect it, it goes into quadrant 1 where I want it. Okay, so when you have a negative radius, remember there's that 180 degrees reflection. We need to do part C. Okay, so part C says, hey, I want you to take care of this last one. And the radius is positive this time. If we look at the part C, so radius is positive, but we have to use a negative angle to represent that point. Okay, so once again, plot the point 0, 30. And remember, my radius is negative, or no, sorry, my radius is, shoot, this is moving. Keep on hitting the button, sorry guys. The radius is positive, the angle is negative. Okay, so remember, I have to use negative rotation around. Okay, so to figure out what that is, we're going to take 360 minus 30, and we get 330. Remember, it's negative. Okay, so negative, like positive 330 is 11 pi over 6. But remember, it's negative. So I'm just turning this into radians because that's what they gave the original one in. So what's my answer? My answer for this is going to be 3, negative 11 pi over 6. Okay, so that's A, B, and C. What's the summary here? The summary says a point with polar coordinates r theta, where theta is in radians, can also be represented by either the following: r, theta plus 2 pi k, or negative r, where we take theta, add pi to it, plus 2 pi k. So what they're saying is, hey, you can do multiple revolutions, end up at the same point. We can just name it as something different. And for a negative radius, don't forget that pi is 180 degrees. So we have 180 degrees reflection. Okay, so just to kind of hit that home. All right, we're on objective number 2. Objective number 2 says convert from polar coordinates to rectangular. And to do that, we're going to need some formulas. So if point P is a point with polar coordinates r theta, the rectangular coordinates x, y of P are given by x equals r cosine theta and y equals r sine theta. These little formulas are derived out of the definition of cosine theta and sine theta, where these are not on the unit circle per se. So I don't know if you remember, but cosine theta was given as x over r, where x is a value over the radius. And sine theta was given as y over r. So if I isolate x or if I isolate y, I have to multiply both sides by r. So I get r cosine theta equals x when I do that, and I get r sine theta equals y. So that's where these formulas came from. You already know the formulas, so all you have to do is just manipulate what you know to get the new formulas. So let's go ahead and use them. Find the rectangular coordinates of a point with the following polar coordinates. 6, pi over 6. Let's do that one first. So I know that my radius equals 6, and my angle, or theta, equals pi over 6, which is equivalent to 30 degrees. Okay, so I know I have to do rectangular coordinates. Remember, rectangular coordinates are x, y. So I'm going to go ahead and look for x first. And by definition, x is equivalent to r cosine theta. So x is r, which is 6, times cosine at 30 degrees. Okay, cosine at 30 degrees is radical 3 over 2. So if I take and multiply 6 by radical 3 over 2, I am left with 3 radical 3. Let's do y. So y equals r sine theta. So y equals r times sine of pi over 6, or 30 degrees. So y equals 6 times sine at 30 degrees, which is 1/2. So half of 6 is 3. So I'm not done because my last step is to write this up as a coordinate. Notice that 6, pi over 6 would be equivalent to quadrant 1. And I get the values of 3 radical 3, which is positive, 3. So this is part A, and this is my answer in rectangular coordinates. Part B, we have -4, pi over 4. Okay, so let's go ahead and take care of this. The radius is -4, and theta is -45 degrees. So remember that x is given to us as r cosine theta. X is r, which is -4, times cosine at -45 degrees. And I don't know if you remember, we can't have a negative inside the parentheses like that, so I have to use the even-odd properties. And I know that cosine is even, which means that the negative pops out and becomes positive. So x equals -4 cosine of 45 degrees. So x equals -4 cosine at 45 degrees is radical 2 over 2. So this becomes -2 radical 2. All right, let's do y. So y equals -4 sine of -45 degrees. Remember that sine is odd, which means that the negative comes out and stays negative. So y equals -4 times radical 2 over 2, because that's what sine is. So y equals positive 2 radical 2 when you do all the math. So what are the coordinate points? Coordinate points is -2 radical 2, 2 radical 2. So I write down my x coordinate, then my y coordinate, and I'm done. All right, so let's look at what happens if we have to go backwards. So the first step with this especially is always plot the point, because you're going to see when I have to find theta, it depends on what quadrant I'm in, what I do with it. So you got to make sure that you plot it first, or know where is your original point. If x equals 0 or y equals 0, use your illustration to find r. So how do I find r? It equals the square root of x squared plus y squared. And by the way, this comes out of Pythagorean theorem. So remember, c squared equals a squared plus b squared. So it's the same thing because you're finding the radius. Step 3, find theta. Okay, theta, if it's in quadrant 1 or 4, you're just going to use the equation that theta equals inverse tangent of y over x. Okay, the reason why we're using tangent is because tangent is the only function that equates, well, I shouldn't say the only one because cotangent does as well, but it's the only one that relates y and x together. Okay, and to solve or to get theta by itself, I have to take inverse tangent of that. So that's where that formula came from. But we have to be very, excuse me, we have to be very careful because the range of inverse tangent is negative pi over 2 to pi over 2. Okay, so when you use the inverse functions, you only get 2 quadrants out of that because this is quadrant 4 and quadrant 1. Well, what do we do if we are in quadrant 2 or 3? Inverse tangent does not work with that. So what you have to do is you have to use the same formula, inverse tangent of y over x, and then you're going to have to add pi to this. So this is very important. If you're in quadrant 2 or 3, you have to add pi. And that's why in step 1 it says always plot the point. Because if you don't know what quadrant you're in, you're not going to know what to do at the end. Okay. And the other formulas we have is r squared equals x squared plus y squared. Like I said, if you get r by itself, we get x squared plus y squared under the radical. So let's go ahead and do this. Find the polar coordinate of a point whose rectangular coordinates are -1, comma, negative radical 3. So first of all, what quadrant am I in? So if I look at this, I have -1 here, and let's say this is negative radical 3. I know that that point is going to be in quadrant 3. Okay, if I'm in quadrant 3, I know I'm going to have to add pi to the theta value. Okay, so let's go ahead and find the radius, which should be easier. So r equals square root of x squared plus y squared. And remember that -1 is x and negative radical 3 is y. So let's plug and chug. So r equals x squared, -1 squared, plus y squared, negative radical 3 squared. So r equals 1. Negative radical 3 squared is going to give me a positive 3. So r equals the square root of 4, which is 2. Okay, I have my radius. So cool. Now I have to go and find theta. So remember, to find theta, you have to take the inverse tangent of y over x. Okay, so theta equals inverse tangent of y, which is negative radical 3 over -1. So if I clean this up a little bit, I know that a negative divided by negative is a positive. So I can use my 30, 60, 90 triangle to find out what theta is. Okay, so if I highlight what I want, radical 3 over 1, because remember tangent is opposite over adjacent. So opposite over adjacent gives me back 60 degrees. 60 degrees or pi over 3. Remember that I'm in quadrant 3. So I have to add pi to this value because when I use inverse tangent, that only gives me quadrant 4 or quadrant 1. So let's go ahead and do that. So pi over 3 plus pi. So pi over 3 plus 3 pi over 3 equals 4 pi over 3. So what is my coordinate point? I have to put these pieces together. Remember, in polar, it's r comma theta. So the radius is 2, and theta we just found out to be 4 pi over 3. So it doesn't matter what quadrant you are in initially. So that way when you use that quadrant, you can answer the question. All right, so this is the last objective. Transform an equation from polar to rectangular form. You have to use what's in your toolbox. And by the way, if we're going from polar to rectangular, and we have this equation, r equals 6 cosine theta, we want everything in y's and x's, because remember, we're going to rectangular, which is Cartesian. So here's what we have, or what we know. R equals, or I should put x, sorry. X equals r cosine theta. We also know that y equals r sine theta. And we also know that r squared equals x squared plus y squared. So with that being said, and that's how I, go back and forth from polar to rectangular, I'm looking at my equation. It says r equals 6 cosine theta. Well, if I could get an r in front of cosine, I could substitute in x in for that value. So what I'm going to do is I'm going to multiply both sides by r. And let's see what happens when I do that. So r times the given r. And then I'm going to put r here times 6 cosine theta. All right, so r times r is r squared. And if I move the 6 in front of the r, I get 6r cosine theta. Now I can use substitution. I know that r squared can be substituted in for x squared plus y squared. Because remember, that is what r squared equals. And now I'm going to leave the 6 alone, but r cosine theta is equivalent to x. Okay? So I have this equation, and it says identify the graph. If I'm looking at this, I have x squared and plus y squared, so I know it's a circle. But to write the circle up in proper form, I should have x minus h squared plus y minus k in parentheses squared equals r squared. What I'm going to do is I'm going to move the 6x over. So this is going to be minus 6x. And I'm going to leave a spot there and move the negative, or move the y squared over so it becomes negative y squared theta. Now I'm going to complete the square. And the reason why I'm completing the square is because I want my equation to be in this formula. And in order to do that, I have to have a perfect square trinomial. That's what completing a square does, to allow me to write this up in that manner. So to complete the square, you're going to half your middle term. And my middle term is 6. So half of 6 is 3. And then I'm going to square it. So that becomes 9. So I have x squared minus 6x plus 9 equals negative y squared plus 9. Because if I add 9 to one side, I have to do it to the other. Now, this side on the left becomes a perfect square trinomial. And that's what completing the square does. So therefore, that factors out into x minus 3 quantity squared, because it's x minus 3 times x minus 3. That's what's beautiful about completing a square. It allows us to do that. And on the other side, I have negative y squared plus 9. So in order to finish this up, so I have it in a proper form of a circle, because remember, proper form is x minus h quantity squared plus y minus k quantity squared equals r squared. I just have to move things. So I'm going to leave the x alone. X minus 3 quantity squared is good. I'm going to move the y squared over the other side, and I'm going to leave 9 sit on the other side. If you want to make this so we can clearly see what the radius is, remember 9 is a perfect square. So I can write this as x minus 3 squared plus y squared equals 3 squared. And now I am done. So what does that tell me? That tells me that the center of my circle is 3, 0, and my radius is 3. So that's how I know this is a circle, and this is a proper way to do it. I don't know if my math lab is going to make you do this or not. However, please note you can find a circle and information about it if you write it up in its standard form. Okay, last one. Transform the equation into 4xy equals 9 from rectangular coordinate. So I want polar. So once again, remember x is equivalent to r cosine theta and y is equivalent to r sine theta. So I see an x and I see a y. I'm going to substitute in. So I start with 4xy equals 9. 4, now when I see x, I'm going to plug in r cosine theta. And whenever I see y, I'm going to plug in r sine theta. And then equals 9. Now, I'm going to take and swing the 4 over to the other side. So I'm going to divide off by 4. And when I do that, I get 9 divided by 4 on the right-hand side. And finally, I'm just going to take the r squared. R times r is r squared. Cosine theta, sine theta equals 9/4. So there you go. That is the equation of 4xy equals 9 written in polar form. So it's a polar equation. Okay, and that's it. I know this one was kind of long, but I wanted to power through it and not break it up. You are done with 10.1.